This is Saxon Advanced Math Lesson 86, and I'm sure you guys are excited about this. Arithmetic progression, arithmetic means. This is good stuff here, so let's talk about some definitions first. First of all, what's a sequence? A sequence is something that follows in order. It follows in a definite order. We like sequences. As humans, we fill in sequences all the time. You know, 2, 4, 6, and everybody says 8. Yeah, it's easy, right? We understand sequences. But and music is built on sequences, and much of life has sequences to it. But a sequence has a definite order to it. It's not like I'm looking at a set of numbers saying that there is no way to figure out the next one. That would be random. That would be the opposite of a sequence. Now, there are two types of sequences we're going to talk about. A finite sequence, and this has a set number of elements. If I said I'm only dealing with even numbers between the 0 or between 1 and 9, but only even numbers, there's a sequence. Every other is a even number, 2, 4, 6, 8, and that's it. It's finite. It's done. Infinite means it has no end. Now, infinite sequences are interesting because they don't always go up. Sometimes because if the difference between them is a negative, they'll flip back and forth. They may go down. We got all sorts of things that can happen here. So, and then the next thing here, that is arithmetic or progression, when you talk about that, okay? Progression's easy. It means to go forward. Arithmetic progression, this is the constant value being added. The next thing is common difference. If I said 2, 4, 6, 8, the common difference between any of the elements, so any element minus the previous element, gives me the common difference, and that common difference is 2, right? If I say 1, 5, 9, my common difference is 4. So it's very easy. A common difference can be a positive or a negative number. The next thing is, instead of calling these elements or individual pieces elements into it, we're going to call them terms. Okay? And that's not too bad. We like the word term. It's easy. But the end terms, we have a first term and a last term, but anything in the middle are called means. And we'll get to that in just a minute. Example 86.1 says arithmetic sequence, find an arithmetic sequence where the first term is negative 14 and the common difference is 10. Well, this is pretty easy. If the common difference is 10, that means that between the first term and the second term, there is 10 value points, right? And then between the next one and then after that is 10 more. So my first term is negative 14. Well, what would I find in the second term? This is really easy, right? I would just say 10 more, and it's negative 4, and then 10 more is 6, and then 10 more is 16. And I found all 4 of those. Now, I want us to notice something. What we're doing is we're saying, after we got to the first term, we're saying this is how many times I use the number 10. So I'm saying the one less than the term number. I'm using the common difference once in the second term, twice in the third term, 3 times in the fourth term. Well, wouldn't we be able to therefore just summarize that and say whatever term number I'm looking for minus 1 times the common difference added to the first term would give me whatever term I'm looking for, the value of the nth term, right? So let's put that in a formula. The value of my first term plus the number in the term I'm looking for, right? The number of the term minus 1, okay? Because it's 1 less, right? That's why I'm only using it once in the second term, twice in the third term, times the common difference. So if I wanted to find the fourth term here, and I said my first term is negative 14, it would be negative 14 plus n minus 1, so 4 minus 1 is 3. 3 times 10 is 30. Isn't that what we're doing here? 3 times 10, there's 3 sets of 10, plus the first term. Very simple formula. Now, I'm going to modify this formula in just a minute here, just a hair, and you're going to see why that's so important. This is example 86.2. Find the 25th term. The common difference is negative 6, and the first term is 12. Now, we just went away from the review on Algebra 1 over here to all of a sudden, whoa, 25th term, are you kidding me? Do you know how long it's going to take me to write this out? And if I did it like we did this one, I would have to write this 25 times? That's ridiculous. There's got to be a way to shorten that. So I'm going to use my formula, right? My formula is going to be here, a plus n or minus 1 times d. Well, what's the first term? They told me it was 12, so I'm going to stick that in here. Then they said that the 25th term, so 25 minus 1, and then I'm going to multiply that by my common difference, which is negative 6. So 25 minus 1 is 24. 24 times negative 6 is negative 144. Add that to 12 and I get negative 132. And it's really that simple when they're numbers like this, right? And this is extremely easy for students to grasp because it's like, oh, hey, if I memorize this formula. But I want you to not just memorize a formula. I want you to be able to rederive that in your head because that's just one more formula to memorize. But really what I'm doing is I'm saying one less than the number of term I'm looking for times the common difference plus the first term is all I have to remember. Okay, now, look at example 86.3. Insert 3 arithmetic means between 2 and negative 4. Oh, man. Now, the book, if you're following along, has you set up all of these little dashes, right? And they have you try to figure this out by using the algebra. And I'm going to go ahead and just use my handy-dandy formula. But I'm going to set that equal to the value of the number of term that I'm looking for, right? So I'm going to say the value of the number of the term equals my A1 plus N minus 1 times D. What don't I know? Well, I don't know the common difference. That's my variable, right? Do I know any of these terms? And I'm going to say, yeah, I know these terms. What if I want to use this one? I say the value of the fourth term, right? 1, 2, 3, 4, fifth term. Okay, so I'm going to say the value of the fifth term is negative 4. Well, if I'm going to find the value of the fifth term, I'm going to say negative 4, because that's a value they told me, right? It was right there. And I'll put that in. Negative 4 equals 2. That's the value of the first term. Plus 5 minus 1. Where'd the 5 minus 1 come from? Well, they asked me to fill these in, right? 3 in the middle and 1 on either end is 5. So I have 5 terms minus 1, which is 4. 4 times D. Now, I go ahead and move this 2 over, get negative 6. Divide both sides by 4, which is giving negative 6 over 4, which is negative 3 over 2 when I reduce that. But I'm going to use this as a decimal because we just add decimals so much quicker. So I'm going to say negative 1.5. That's the same thing, and I think most of us are okay with that. So I go back and I say, well, if my first term is 2, and I'm going to add a negative 1.5 to that. Well, 2 plus negative 1.5 is, well, 0.5. And then if I did the next one, 0.5 plus a negative 1.5 is negative 1. And then I did the next one, negative 1 plus a negative 1.5 is negative 2.5. And then I did that again just to check it. Negative 2.5 plus a negative 1.5 is negative 4. And this is really that easy to work with. Now, I'm going to do something I usually don't do, and that's move the camera as I'm doing this. And part of it is I just ran out of room. I wrote in the corner of my board. So excuse me as I make everyone seasick here. And we move this over here, and I look at it. This is example 86.5. Now, like I said, I apologize for the wonderful movement of the camera right in the middle, and how unprofessional can I get, right? So let's look at 86.5. And this one says find the 10th term of an arithmetic sequence in which the first term is 3x plus 2. Oh my goodness, what are they doing to us now? They're putting in here algebra in a term, in a sequence, okay? And the sixth term is 8x plus 12y. Now, this is where it gets to be a little exciting because I have to use what I just came up with over there, and that is I want the value of the sixth term, right? What is that value of the sixth term? Well, I know the value of the sixth term, so I put that in. It equals a1 plus 6 minus 1. Where did this come from? This is the sixth term, minus 1, times the common difference. Well, I need to find this common difference again, right? That's what I'm looking for. Do I know the value of a1? Sure, it's 3x plus 2y, so I plug it in. Do I know the value of the sixth term? Yes, I do. It's 8x plus 12y. And I put that in. So now I have this wonderful algebraic equation that I can simplify down. If I say take away 3x from both sides, I get 5x. Take away 2y from both sides, I get 10y. And I'm left with 5x plus 10y equals 5d. Now, at this point, I divide everything by 5, right? And I say my common difference is x plus 2y, which means that even though we don't think of this being a sequence because of the variables, it is, and this sequence goes up by a value of x plus 2y every single term. Now, they want the 10th term. I could take my sixth term, find a seventh term by adding this, find an eighth term by adding this, find the ninth term by adding this, find the 10th term by adding this. That sounds really cumbersome. So I'm going to use my same formula again, but I'm going to say the value of the 10th term, that's what I'm looking for, right? Equals my a1, 3x plus 2y. And I'm looking for the 10th term, so 10 minus 1 is 9, times my common difference, x plus 2y. And these are really simple when we get it down to using a formula and letting the math work itself. Instead of trying to comprehend that all in my head, I'm just going to let the math work through this. 9 times x is 9x. 9 times 2 is 18. Now I can combine some like terms, right? I don't need those parentheses anymore. 3x and 9x is 12x. 2y and 18y is 20y. And suddenly I'm left with a value of the 10th sequence or 10th term of the sequence, and that's 12x plus 20y. And we took something that looked terribly difficult and made it into something that's pretty easily understandable as long as I remember those things. And that is, make it into a formula that you can use. And then once you have that formula, let the algebra work its way through, and it's amazing how that will work for you.